பயனடைமாறு அன்புடன் கேட்டுக்கொண்டு ப்ரொஃபசர் அருமைராஜ் அவர்களை இந்த அவைக்கு அறிமுகப்படுத்துமாறு டாக்டர் என்ஜிபி இன்ஸ்டிடியூட் ஆஃப் டெக்னாலஜியின் சிவில் துறை தலைவர் ப்ரொஃபசர் முத்துப்பிரியா அவர்களை கேட்டுக்கொள்கின்றேன். நன்றி, வணக்கம்.
Thank you, sir. Good evening, all of you. I am delighted to welcome all of you for the virtual internship series 1 organized by Builders Association of India, Coimbatore Center. I am very much happy in introducing today's resource person, Dr. P.D. Arumairaj, sir. At present, sir is principal consultant of Alzum Geocivil Integrated Services, Coimbatore. Sir completed his BE Civil Engineering in 1984 from Regional Engineering College, Trichy, and sir completed his PG ME in 1989 from Government College of Technology, Coimbatore, and PhD in Soil GIST program in the year 2006 from Government College of Technology, Coimbatore. So served as lecturer, assistant professor, associate professor, professor and head in various government colleges in Tamil Nadu. From 2016 to 2019, after his retirement from Government College of Technology, he joined and worked as professor and head in School of Civil Engineering, Cornell University, Coimbatore. Totally, sir has more than 30 years of teaching experience and also consultancy experience. He is a member of various professional societies. Sir is fellow in Indian Geotechnical Society, member in Indian Society for Technical Education, fellow in Institution of Engineers, chartered engineer, member in IEEE. He is a chairman of Indian Geotechnical Society, Coimbatore chapter. He was the head of consultancy division in GCT Coimbatore before his requirement. So served as board of studies member for Anna University, Bannariamman Institute of Technology, Kongu Engineering College, Sri Krishna College of Technology, Sri Krishna College of Engineering and Technology in Coimbatore region. Sir was approved PhD supervisor, and under his guidance, several candidates completed their PhD. Sir published more than 30 papers in national international journals and more than 30 papers in national and international conferences. Sir has organized more than 50 sponsored programs like workshops, seminars, conference, and in international and in national level. Sir has carried out many consultancy works. Few are solid waste management project for Coimbatore Corporation at a cost of rupees 110 crores. Road works in Coimbatore Corporation at a cost of rupees 200 crores. We are happy to have you as our resource person, sir. Thank you for accepting our invitation. Sir, talk about evaluation of safe bearing capacities of soil in site. Sir, thank you very much for accepting our invitation. Your support will enlighten the students' future. The forum is yours. Thank you, sir.
Hello.
Shall I start now?
Yes,
Sir, can you please be audible, sir? Konja pesing, sir.
Shall I start now?
Yes, sir. Very good, sir. Thank you, sir. Or chinnade. Do you have a presentation?
Yeah, I have a presentation. Yeah, PPT is there.
Sir, then we have to make you as an admin, sir. So from your screen, you can share the presentation.
Okay.
So once your speech is over, you can transfer the admin back to me, sir. Okay.
Okay.
Prakash Angar. Okay, sir. Thank you, sir. All the best. Panir, sir, அதை சொல்றீங்களா?
Yeah, இல்ல டாக்டர்.
Before I go to the presentation, I take this opportunity to thank the Builders Association. We have close association as pointed out by the president. We have been in good communication for the past 5 to 6 years. And when I was the professor, the students were sent for internship. If I remember correct, when I was in Karunya, a student won a prize and BA awarded a prize to them also. I think meeting was held in near Vadaveli on the Tondamuthu Road. So I'm always, thankful to you. And, you are the people who are really in the field. And now, your concern for the students and the internship will be definitely useful. Now AICT, they have planned that every undergraduate student, BTech student, should have an industry exposure. So they have stressed on that, and BAI is in line with that. You are doing all these internship out of a busy schedule. But anyway, I thank once again for the opportunity given. I should also thank Professor Muthupriya for the kind words of introduction given. My association with Madam was also quite long. So hopefully, I think these students will be benefited out of this lecture. And I wish that we continue to do these programs for the benefit of the students. Thank you.
Thank you, sir.
Sir, Arumairaj sir, you can start. I'm now transferring the admin to you, sir. Only the only request will be, sir, there may be late entrants coming into the Zoom app, sir. Just
Okay.
you have to allow them by the waiting room flash will come to you from the bottom. You just have to keep them allow. That's all. That you have to also kindly see, sir, because
Yes, sir.
you will be the admin to allow them inside the meeting, sir. There may
Okay.
not be much, but few people. But
Okay.
please take care of that, sir. Sorry for this thing. Now I'm transferring you the admin rights, sir.
Thank you. Admin rights.
Yes, sir. I have done the admin rights, sir. You can proceed, sir. And also I'm putting you under the speaker view mode, sir. Yes.
Okay.
Please proceed, sir. Thank you. Best of luck, sir.
So the startup trouble with me in placing the slides.
No problem, sir. We just saw you opening it up. Right, sir. Fantastic. Fantastic.
Perfect இருக்கு சார் ஸ்கிரீன் உங்க
Super. Proceed, sir. Proceed, sir. Please proceed. Thank you. Thank you.
Okay. So good evening, everybody. The respected office bearers of Builders Association, other professors, and the student friends who are on online internship. We are going to discuss on evaluation of bearing capacity of soil. So in fact, many people may not be familiar with the soil, because in all these structures we see what is above the ground. Soil and foundation, everything is lying below the ground. So normally the soil will not be recognized or admired by people, whereas they will admire the buildings that is standing above the soil. But at the same time, we should also understand. I had the chance of visiting that area when I was attending a program in Nagpur. But there,
Agreement.
hello. In that area, when I visited that area, I found that some buildings were standing straight, whereas the building nearby had collapsed or even raised to the ground. I was wondering when I asked the people who guided us to that particular site, and they said the buildings which stand or which has withstood this earthquake or engineered buildings.
கண்டிப்பா நான் சொல்றேன்.
I would rather say that buildings were designed taking into consideration the seismic forces also. So that is very clear. When a situation or a worst situation happens, the buildings could still stand if it is an engineered one. What is that we understand by engineered building? It should be safe. எல்லாருக்குமே வந்து நம்ம கட்டுற கட்டடம் சேஃபா இருக்கணும்ன்றதுதான் முக்கியமா இருக்கும். At the same time, it should be durable. சேஃபா இன்னைக்கு மட்டும் நின்னா பத்தாது. அது என்ன டிசைன் லைஃப் கொடுத்துருக்கோமோ 50 years, 75 years, என்ன லைஃப் கொடுத்துருக்கிறோமோ it should stand up to that life also. At the same time, it should be economical. Nowadays, you know, in the competitive world, people should be provided the construction at an economical cost and at the same time timely completion. So all these four have to be considered by in the engineered building. So for that, every engineer, every builder should have a knowledge of all the aspects of the building. When about 30 years back, when a design is given to the field, they will mention in the foundation portion, they will simply mention foundation suiting to the site conditions. Foundation பத்தி டிசைட் பண்ணிருக்க மாட்டாங்க, ஃபவுண்டேஷன் என்னன்னு சொல்ல மாட்டாங்க, எவ்வளவு டெப்த் போடணும்னு சொல்ல மாட்டாங்க. பட் அதுல ஒரே ஒரு லைன் இருக்கும், அங்க இருக்க சைட் கண்டிஷனுக்கு ஏற்ற மாதிரி நீங்க ஃபவுண்டேஷனை டிசைட் பண்ணீங்க அப்படின்னு இருக்கும். பட் அதுல என்ன ப்ராப்ளம் வரும்னா, ஆஃப்டர் டெண்டரிங் இஸ் ஓவர், கான்ட்ராக்ட் இஸ் ஃபிக்ஸ்ட், அதுக்கப்புறம் என்ன ஃபவுண்டேஷன் போடணும் அப்படின்னு நம்ம யோசிச்சுட்டு இருந்தோம்னா, பை தட் டைம் you know the timely completion children, it will drag and there may be complications also in the foundation. So that is now we are able to overcome that nowadays. We do the soil investigation prior to the or before undertaking the construction. So, very good improvement and we should appreciate it.
ஆமா, அங்க இருக்க ஜாமான கொஞ்சம் ஏத்தி விட சொல்லி தேவையில்ல.
So initially I just show some of the pictures which are familiar to you. I have just downloaded from the net.
நாளைக்கு வேலைக்கு இருக்கா?
Which are familiar to you, just to show you to understand the importance of the foundation. So I will just have a quick pausing of these slides. You know,
ஒரு 23 இறக்கலாமா?
This is a new terminology probably you may come across. Probably in the metro.
நினைக்கிறான் அவன், பணம் கொடுக்கணும் நினைக்கிறான். அந்த ஓனர் தான் நாராஜ்.
Hello. Excuse me, but there has been cross talks also. So the sinkholes which were not had of earlier, now you know in the nearby areas of Cochin and Chennai, metro projects are implemented, and at times we come across, you know, there is a sinkhole formed in the road, sinkhole formed in the line that was executed. So these are all certain things that we should know, and how these sinkholes are formed. Next, just have a look. These are only to show you some of the pictures. See why an investigation, how the evaluation of bearing capacity should help us. That is the thing. Next. These are all some failures, you know. Yes. Next. Then frost heave. So when I studied the subjects, when I was a student, I thought we have been studying so many things. Are we really going to execute all these things? whether all these things are relevant to our education, I used to have that doubt. But now, once I am in the picture as a teacher and as well as an engineer and as well as a consultant, I find that every line that you study in your subject is being there in the practical field. So that you should always understand. Normally, we'll ignore certain portion, or we'll omit certain portion, but anything that is given in your syllabus, now, in almost all the universities and the colleges, the syllabus is recast, field oriented. What is needed in the field is included in the syllabus. So every student should be careful to concentrate on every part of the syllabus, and I am sure that it will have application in the field as well. Next. This is again some failures I'm just showing: sand boiling, ground cracking, and ground heaving. Next. And you see overturned apartment complex. Even today we saw it in the newspaper in Mumbai, a building had collapsed today. So, how many loss of life, we do not know. And yet, this is what the Bhuj earthquake, which I was referring to, probably in the next picture, you can see a few buildings. Okay, next one. Okay. So I had showed some of the pictures just to show that there are failure in the buildings. And in fact, as a geotechnical expert, I should thank the failure of the buildings. I should not really thank like that, but only after the failure in buildings, people have started realizing the importance of geotechnical engineering. When I talk about the geotechnical engineering, people have started the importance of the foundation. Here there is a small projection. You can see the load path of the building. So first you see at the roof, there may be some live load, dead load over the roof. How the load transfer is taking place, just have a look at it. So from the top, the load is transferred to the beams. Roof beams are there. The arrows are shown there. And we take a lot of care in designing the beams also. It can be a singly reinforced beam, doubly reinforced beam, a pre-stressed concrete beam, maybe a steel section. We take a lot of care because, it has to take care of the load coming over the roof, including the roof slab. So we are aware of it. Then the load is transferred to the columns. Now we are again careful in designing the columns. It should not be a long column. The column should be reinforced properly. Size of the column should be okay. And according to the codes, now you cannot have a 9-inch by 9-inch column. The minimum lateral dimension should be 1 foot. We are careful in so many aspects in designing the column because we know it has to support the loads coming over there. Then the load is transferred to the foundation. Slowly people have understood, oh, foundation is also important. Now people have understood, okay, foundation is also important because all the load have to be ultimately transferred to the foundation. But it doesn't stop there. That is the thing everyone should realize. It doesn't stop there. From the foundation, where does this entire load goes? It goes into this underlying soil. It goes into the underlying soil. But what about the soil? Do you have any idea about the soil? Do you have any interest in the soil? Just imagine, we have taken so much of care up to the foundation, but we are not taking enough care to understand the soil. To understand the soil. Soil is a naturally occurring material and it is heterogeneous in nature and it differs from place to place. Unless we do a proper investigation, we may not come to the proper design parameters by which the foundation can be rested on the soil. And do we have any idea what are the different types of soils? What will be the problem that will be created by the soil? Though our topic today is mainly the evaluation of bearing capacity, then on what basis we should evaluate it? So that is also very much important. And people, they do not pay attention to the foundation, mainly because it is buried underground. And one more thing that everyone should understand, if there is a small problem in the roof, now the technology has grown, you can cut that portion of the roof and stick another portion of the roof over there. If the beam has created any problem, even that can be retrofitted very easily. Give a support. Even if you want to cut that portion of the beam, insert another portion, that is possible now. A lot of construction chemicals are there in the market. And the column, there is a problem in the column, one column or two columns. The columns can be individually retrofitted very well. But if something problem in the foundation, can we rectify it or can we not rectify it? But in today's world, particularly in the civil engineering field, nothing is impossible. We can do everything. But at the same time, if there is a problem in the foundation, then the cost of retrofitting or the cost of rectification of that foundation, because if the foundation fails, it affects the entire structure. Probably you may come across at a later stage the process of underpinning. Underpinning is almost you provide another temporary foundation for supporting the entire structure. Okay, it is good, but what about the cost of it? That is costly. Even 30 to 40% of the cost will go in the process of underpinning itself. So that is why the foundation has to be taken care of. And the performance of the foundation mainly depends on the underlying soil, behavior of the underlying soil, or the properties of the underlying soil. So this is very important that we should always keep it in mind before we take up any construction. And I was I was a professor for, of course, as introduced. But during the course of my profession, I was in a lot of consultancy projects. And many designers, they used to come to us for any doubt in the design of foundations. So I used to ask them, no, now you have been the leading designer and you have been designing wonderful structures. And when it is a foundation, probably why you are not able to, why not spending time to refer to that and solve it. Out of interest, I used to ask them, they said, sir, this oil mechanics and foundation, right from our study in the BTech level, it was a gray area. So we thought, we'll leave that gray area as it is. So still we are considering it as a gray area, and probably we can just keep it like that. But I am sure, not because I got interest in geotechnical engineering. Geotechnical engineering or your soil mechanics and foundation is really an interesting field because you are dealing with a lot of uncertainties, challenges. See, if you want to design a building, if I am sitting in my room, if I have to design a building, if I'm given the plan, if I'm given all the details that are needed, I need not even move out of room. I can do the design and send it. But if I have to decide about a foundation, if I have to design a foundation based on a soil investigation, do you think that I can sit in my room and design the foundation? Do you think so? It is simply not possible. It is a foundation man has to go to the field first, and he has to ascertain the soil conditions. And many times people think, even during course of my profession, many people used to bring soil sample in small plastic bags, and that they carry the samples, and they used to ask me, sir, look at the soil sample. Can you please tell me, I'm going to construct a building, maybe a residential building or some building, but can you tell us, give an idea about the bearing capacity of the soil? Then I used to tell them, no, this bearing capacity has to be confirmed in the field. It is based on the field condition. It is necessary for me to come to the site and see and conduct and test in situ. But they will keep on asking, sir, எவ்வளவு நாள் அந்த இதுல இருக்கீங்க? நீங்க 30 வருஷமா இருக்கேன்னு சொல்றீங்க சார். இந்த சாயிலை பார்த்து கொஞ்சம் ஐடியா கொடுங்க சார். ரஃபா எவ்வளவு தாங்குன்னு சொல்லுங்க, போதும் சார். பட் உங்களுக்கு ஒரே ஒரு இது என்னன்னா, சப்போஸ் dense sand which is as good as a rock, which is capable of taking the N value of nearly 100, if you excavate that sand from the site and take it in your hand, then it is nothing but a loose sand. A sand collected from the riverbed and a sand excavated from the densest condition in situ will appear to be the same for me when it is brought to me in the laboratory. Maybe we can think of taking some undisturbed samples, but there are a lot of things to be commented on that. So why I am mentioning this, as we go for this foundation design or deciding the type of foundation, the parameters of the soil have to be decided properly, for which we have to necessarily go to the field. We cannot avoid the field. And probably some of you might have seen or you might have studied that the equipments that are needed for testing the soil in the field is also heavy machinery. And you see that machineries have to be taken to the field. And if heavy machinery to be handled, and it is laborious also, labor are required. So just see the situation. You need labor, you need machinery, and you have to go to the field, and you have to conduct the test in the field. It doesn't stop at that stage. And the sample has to be brought to the laboratory, and it has to be analyzed in the laboratory. And another important thing that I want to share here is, even to determine the moisture content of the soil, we need 24 hours. But if we conduct other tests, probably I will be discussing about this when I discuss about the settlement. I can say about the consolidation test. If we need to conduct a consolidation test, the time taken will be nearly 3 days, 4 days, depending on the loading conditions. But everybody will be in a hurry to get the soil investigation report at the earliest possible time. So the moment the test is over, people will start asking, sir, when will I get the report? Will I get it tomorrow? Or will I get it day after tomorrow? But one should understand that it involves time also. And when it involves time, when it involves labor, when it involves some equipment, definitely it will be expensive also. And we must be prepared for it. But at the same time, I can tell you, if you are really able to assess the correct properties of the soil, if we are really able to assess the correct bearing capacity of the soil, you can save cost to the tune of nearly 20 times more than what you spend on the soil investigation. In your size of the footings, in your type of the footing, in the reinforcement, in the cement, sometimes even in positioning the column also, you can save enormous amount. But don't look at the cost involved in the soil investigation. That is going to help the stability of the structure, not only the stability of the structure, but also save a lot of cost on the construction of building. So this should be borne in mind when we plan for a soil investigation. And there should be, I can tell you one example, probably in one of the leading institutions in Coimbatore. I am just sharing with you, something happened 25 years ago. So the executive engineer from the particular institution came to us and he said, sir, we have to do a bearing capacity test. Then I said, okay, we can very well do that. That time, of course, I was only an assistant professor, maybe with an experience of 5 to 6 years. I had a professor called Azaria Dhanasingh. So I used to discuss with him about what to be done. Then I told that engineer, sir, we will visit the site and decide about the test. Then he asked what will be the cost of that. So about 25 years back, I told him the cost will be about 1,500 rupees. But you know, that executive engineer simply asked me, sir, can you not do it for 300 rupees? I was wondering, sir, this is the minimum that we give because we are from government and you are also from almost another university. But no, sir, it is very costly, he left. I can name the building which was constructed subsequently without proper investigation. That is still there. But after the building is constructed, after a year or so, one engineer from the same university came to me. Sir, we constructed a building that has cracked in all possible ways. Can you now come and have a look at it and suggest why it has cracked? Can you suggest remedial measures? But I understood before they came to us, twice or thrice they had repaired the building and they had spent lakhs of rupees in repairing the building also. When I visited the building, I could recollect it was the same building for which the investigation was sought from us. And, for a matter of 1,500 rupees, they ignored that investigation and they had sent lakhs of rupees on the investigation of the building. So this happens in several places. And unless we go to the right people for the right investigation, then probably we may land up in trouble at a later date. So the correct assessment of soil is essential. So the understanding the concept of that is also essential. Probably I take this opportunity to present before the students, because unless the students develop interest in that, now today's young people, all budding engineers, they will concentrate only if they like it. If they don't like it, they will ignore it also. Previously, you can recall the days of senior people. They were all bothered about the studies. Now, they are quite intelligent, but they need to be motivated or the interest is kindled among themselves. அதாவது சொல்ல போனா அவங்களுக்கு ஒரு இன்ட்ரெஸ்ட் உருவாகும். Interest இருந்தாதான் they will study. Interest இல்லைன்னா they will not bother to study also. So that is one thing. And as far as the civil engineering is concerned, it is all about soil. Because I used to hear from one of the vice chancellor from renowned university, he used to say, civil engineering is all about soil. And mechanical engineering is all about oil. And electrical engineering is all about coil. So these engineers will be struggling with these different materials throughout their lifetime. And the soil doesn't exhibit anything on its own. See, for concrete, if you want M20 concrete or M60 concrete also, can you not get it? You can get it. You can make it. In no time, you can make it. But I have for 5-story building, I need a soil of bearing capacity of 600 kilonewton per square meter. Can I get a particular type of soil? No. I have to deal with the soil that is available in the field. But I can tell you, in the introduction itself, I told you, nowadays, nothing is impossible for civil engineers. Civil engineers are making wonders in the world. And young people know, now you can Google out the different structures, particularly the infrastructure in different parts of the world, bridges, flyovers, tunnels, just hanging towers. Just have a look at it. It is really wonderful how these buildings were constructed. These buildings are constructed by our own civil engineers. Now, a lot of challenges they have faced. And any structure for that matter, whether it is a bridge, whether it is a road, whether it is a tower, whether it is a pipeline, anything is ultimately rested on soil only. So the importance of the soil should be understood the right earnest. I can share hundreds of examples on the part of the failure. Probably I will get into the topic, and wherever necessary, I will just share my field experience so that you will find solutions for the problems in the course of the construction industry itself. See here, when we say soil, நம்ம மண்ணுன்னு சொல்றோம். In தமிழ்ல வந்து மண்ணுன்னு சொல்றோம். மண்ணுன்னா அது நிறைய டிஃபரண்ட் டைப்ஸ் ஆஃப் சாயில். டிஃப்ரெண்ட் டைப்ஸ் ஆஃப் மண் இருக்குன்னு சொல்லலாம். ஒவ்வொரு மண்ணும் ஒவ்வொரு ஸ்டைலா பிஹேவ் பண்ணும். அதான் அதுல உள்ள பியூட்டி. இப்போ இதுல ஐ ஹவ் ஜஸ்ட் ஷோன் அ டேபுலேஷன் ஹியர். டைப் ஆஃப் ஜியோ மெட்டீரியல், சாயில் டைப்னு கொடுத்துருக்கேன். சாயில் டைப்ல பாத்தீங்கன்னா ஃபர்ஸ்ட் ஒன், நீங்க ப்ராபபிலி தோஸ் ஹவ் ஸ்டடிட் தி சப்ஜெக்ட், யூ கேன் அண்டர்ஸ்டாண்ட். சாயில வந்து based on our IS classification, coarse grain soil, fine grain soils in particular. In the coarse grain soils, it involves gravel and sand. It involves gravel and sand. You know, from according to the IS standards, the soil finer than 4.75 mm. The soil finer than soil finer than 4.75 mm and greater than 0.075 mm is classified as sand. It is simply based on the size of the particle. And the soil that is greater than 4.75 is your gravel. And now there is fine grain soil also. Fine grain soil is nothing but clay and silt. And the soil that is finer than 0.075 but greater than 0.002 millimeter is called silt. And the soil that is finer than 0.002 millimeter is called clay. You just imagine 0.002 millimeter. You just visualize what is the size of 0.002 millimeter. Finer than that is clay. Can you look at this clay particle with your naked eye? Sand particle can be individually identified. Gravel can be individually identified. But what about clay? And most of the problem with this soil problem, it generates only from the fine grain soils, mostly from fine grain soil. So we should have a thorough understanding of this. I just tell a few examples before we still get into the actual topic of discussion, because I feel that students should have a focus on why should we study about this. If it is a bearing capacity, what is that? Why should I study about that? What is the botheration it makes to the civil engineers? First one is soft clay, low strength, high compressibility, large creep deformation, low permeability. Clay எடுத்துட்டீங்கன்னா ஒருவேளை எல்லாரும் சின்ன பிள்ளைங்கள வில்லேஜஸ்ல எல்லாம் நம்ம விளையாடி இருப்போம். களிமண் எடுத்து நல்லா தண்ணியை ஊற்றி, இப்போதான் நீங்க எல்லாம் விநாயகர் சதுர்த்தி கொண்டாடினீங்க. களிமண்ல என்னென்ன டாய் முடியுமோ அதெல்லாம் நம்ம பண்ணி பார்த்துருக்கோம். அப்போ அதுதான் நமக்கு இருந்த விளையாட்டு பொருள்னு சொல்லலாம். இப்போ களிமண்ல கையை விட்டாலே பேரண்ட்ஸ் வந்து they will not permit them. அது இப்போ we are in the period of corona. எதையுமே தொடக்கூடாது, இல்லை கிளவுஸ் போட்டு தொடணும்ன்ற ஒரு கண்டிஷன்லாம் இருக்கு. இந்த களிமண்ணை பார்த்தீங்கன்னா it has got a behavior. If you add water, களிமண் வந்து நிறைய இடத்துல பார்த்தீங்கன்னா உடைக்க முடியாதபடி கட்டியா இருக்கும். ஹார்ட் கிளேன்னு சொல்லுவோம். அதை நீங்க எவ்வளவு பெரிய இது வச்சு அடிச்சு உடைச்சா கூட உடைக்க முடியும். ஹார்ட் கிளே. It has got a very high strength. But see, the same clay, when you add water, slowly it becomes soft. When you add more water, now you can play with that clay. Play. என்ன வேணாலும் பண்ணலாம். நீங்க இப்படி வளைக்கலாம், அப்படி வளைக்கலாம், பொம்மை செய்யலாம், கால் செய்யலாம், கை. See, just see the situation. இது விளையாட்டுக்கு மட்டும் இல்லை, even in the field also, when it is saturated with water, its behavior is entirely different. When there is no water, when it is stiff, very stiff, its behavior is entirely different. That is one point that we should always remember. The next one is silt and so. The soft clay ஒரு சின்ன எக்ஸாம்பிள் நம்ம சொல்லிடுறேன். கோயம்புத்தூர்ல there was a water supply scheme, that is Pillur. Now we have Pillur 3 is being implemented. I am talking about Pillur 1. When that was implemented, after it was inaugurated, there was a frequent failure in one particular stretch. Coimbatore water supply is disrupted na enna situation உங்களுக்கு தெரியும். 10 நாளைக்கு ஒரு தடவை தண்ணி வரும், இல்லை 7 டேஸ்க்கு ஒரு தடவை வரும். அதுல இந்த மாதிரிலாம் ஃபெயிலியர் ஆச்சுன்னா அது 15 நாளைக்கு ஒரு நாள் ஆயிடும். அப்போ that particular super engineer, he came to us one day. சார், நாங்க பைப் லைன் எல்லாம் போட்டிருக்கோம், பர்டிகுலரா ஒரு ஸ்ட்ரெச்ல வந்து உடஞ்சிக்கிட்டே இருக்குது சார். There has been constant failures. Then we went there. We went to that particular place. And you know what happened? ஒரு வெஹிக்கிள்ல போறோம், அவங்க டிபார்ட்மெண்ட் ஜீப்ல போறோம். அந்த ஜீப்ல அவர் பக்கத்துல நிறுத்தி இருக்காரு. ஜீப்ல இறங்கி அந்த பர்டிகுலர் சைட்ல கால் வச்ச உடனேயே என்னோட கால் வந்து முழங்கால் வரைக்கும் அந்த மண்ணுக்குள்ள போயிடுச்சு. So my leg has gone deep into that up to knee. அப்ப என்ன அர்த்தம்? There was a presence of clay. Even that clay was very soft. So in the soft clay, நார்மலா பைப்லைன் லே பண்றதுனா நம்ம என்ன நினைப்போம்? சும்மா பைப்பை லே பண்ணா முடிஞ்சு போகுது. பெரிய கட்டடத்துக்கு தான் ஃபவுண்டேஷன் வேணும், சாயில்லாம் பார்க்கணும், இன்வெஸ்டிகேஷன்லாம் பண்ணணும்னு. But in the pipeline, கடைசியில் I am just telling you the solution for a particular stretch which we identified based on laboratory analysis. We provided pile foundation to normally pipes are supported on pedestals, but this we have to provide pile foundation on which pedestal was rested. Then the pipe was laid over the pedestal. So our idea that foundation or soil investigation is necessary only for big structures, infrastructure, that is also not correct. Even for a flow, I can tell hundreds of examples only on soft clay. And in Coimbatore, I got a problematic soil of black cotton soil, which is of swelling in nature, highly expansive. We are, Coimbatore city is known for as a cotton city, and cotton crops were grown in plenty in the earlier days. That is why it is black cotton soil, karpu color. It is highly swelling type. But இன்னொன்னு கலரை பார்த்து ஏமாந்துடக்கூடாது. Highly swelling type soil கருப்பா தான் இருக்கும்னு நினைச்சிடக்கூடாது. அது கொஞ்சம் ஒயிட்டிஷ் கலர்ல கூட இருக்கு. கோயம்புத்தூர்ல I can tell in one of the housing board complex in Upplipalayam, there are perennial problems because of the swelling shrinking. The building cracked, had to be demolished. But that was because of the swelling of soil, shrinking of soil. But at the same time, we should thank that this presence of the soil in most of the area is restricted to shallow depths. If it occurs to a deeper level, then we have to take a lot of precautions. Then silt also, which is very easily prone for erosion, soil erosion, which is prone for liquefaction potential. Recently, there was flooding in Kerala. There are many houses collapsed. Probably we might not have forgotten because many things are happening quickly. Very recently, we had a landslide in Munnar. Hundreds of people have died. Many bodies had to be traced. So we have forgotten about the flooding in Kerala. So in this flooding, what we observed was, water was, it was like a fountain. It was pumped through the floor of the buildings. Why? It was considered liquefaction was occurring. Nobody expected it. Do we expect the earthquake to occur? That's why I told you, in good earthquake, the engineered building stood even after the earthquake. But whatever we build should be able to stand even after the earthquake. And the stability depends on the foundation. That is very, very important. And the stability of the foundation depends on the type of soil. So based on that only, you should go for this. நம்ம என்னதான் சொன்னாலும் நம்ம எல்லாருக்கும் ரொம்ப தமிழ் பீப்புள் எல்லாருக்குமே ரொம்ப பிடிக்கிறது வந்து சினிமா தான். சினிமாவில் கூட ஒருத்தர் சொல்லிவிட்டார், பில்டிங் ஸ்ட்ராங் பேஸ்மெண்ட் வீக். அப்படின்னா என்ன அர்த்தம்? மேல இருக்க கட்டடம் என்னதான் ஸ்ட்ராங்கா இருந்தாலும் கீழே இருக்க ஃபவுண்டேஷன் வந்து ப்ராபபிலி வடிவேல் நினைக்கிறேன், ஒரு காமெடி ஆக்டர். ஸோ தட் சிம்பிளி கன்வேஸ் பில்டிங் என்னதான் ஸ்ட்ராங்கா கட்டினாலும் பேஸ்மெண்ட்டோ ஃபவுண்டேஷனோ வீக்கா இருந்துச்சுன்னா ஒன்றும் பிரயோஜனமே கிடையாது. Then organic soil. Third one is organic soil. High compressibility. The organic soil வந்து it is nothing but made up of organic material. இது hilly regions we are very close to Nilgiris. ஊட்டிக்கு ரொம்ப பக்கத்துல இருக்கிறோம். ஊட்டியில நிறைய இடத்துல ஆர்கானிக் சாயில் பார்க்கலாம். It looked like a soil, but unless you examine, unless you investigate, ஊட்டில நிறைய இடத்துல zero bearing capacity ne soil போயிட்டு. I was involved in exploration in offshore investigation. I had the chance of working in Southeast Asian countries where, we used to do offshore investigation. Even for 20 meters, there will be soil without any bearing capacity at all under the seabed. Most of the soil will be organic soil. If at all there is any resistance, the resistance will be due to the presence of foreign elements. See, கடலுக்கு அடியில ஏதாவது போட்டோட ரெக்கேஜ் இருக்கும், அந்த wood இருக்கும், இல்ல ஏதாவது ஸ்டீல், இந்த மாதிரி இதெல்லாம் ஸ்ட்ரென்த் காட்டுமே ஒழிய 20 மீட்டர் வரைக்கும் zero bearing capacity போயிட்டு. So organic soil, I can also tell lots of example on organic soil. Once I still remember, in one of the building in Kunnur, there was also the building settled uniformly. Floor வந்து கிரவுண்ட்ல இருந்து 2 அடிக்கு மேல போட்ட ஃப்ளோர் கிரவுண்ட்ல இருந்து 2 அடிக்கு கீழே போயிடுச்சு. என்னன்னா யூனிஃபார்மா செட்டில் ஆயிடுச்சு. When we inspected, we collected some soil sample from that site. We kept it in a muffled furnace. Next day when we kept about 500 gram of soil, we were able to take only 320 gram of soil. The remaining was organic content. It was burnt into ash. So what happened to that building? That building was slowly settling down. But fortunately, take the place of Charing Cross, water table will be almost at the ground level for most of the period. But now why we have the basement height and all? To prevent climbing of moisture by way of capillary action to the floor. But here, when it is lower than the ground level and moisture will be there, water will be there. So functionally, the building has failed. Then loose sand. Loose sand, I can tell you one more example. Sand, I told you initially, gravel and sand, there is not much problems. Silt and clay, there are problems. This is a general opinion about it. But loose sand, are we able to, I tell one experience, there was a building proposed close to Marudhamalai, because since we are in Coimbatore, I'm sure all of you may be knowing Marudhamalai. So that one institution was coming up, so that the engineer was known to me, and they had almost started the construction. And that engineer called me one day, sir, we'll go to a site. I know that it is very close to the hill, the soil is very good. But anyway, we'll just go and see what type of soil it is, whether it will take a considerable amount of loading. But normally, in the government departments, previously they used to take the bearing capacity only as 10 ton per square meter or 100 kilonewton per square meter. Even if you give them 250 kilonewton per square meter, they will not accept it. They will take only 100. So the engineer told me, I have adopted only 100, sir. We'll just go and see. We went there, and the previous day there was rain. Maybe rain in this sense, it's not heavy rain, it's somewhat drizzling. We went by their vehicle in a jeep. We got down from the vehicle. We just walked into the site. When we were walking, I could find the footsteps. There was depression formed. The footprints were clearly formed in the sand itself, as if we walked on the beach. Normally, நீங்க பீச்ல நடந்தீங்கன்னா உங்க கால் தடம் அப்படியே தெரிஞ்சுட்டே இருக்கும். கொஞ்சம் வேகமா நடந்தீங்கன்னா இன்னும் நல்லா ஆழமா தெரியும். இங்க நாங்க சும்மா நடக்கும்போது ஆழமா தெரியும். அப்ப என்ன அர்த்தம்? The sand is very loose. Sand is very loose. நம்ம மலைக்கு பக்கத்துல தானே இருக்கிறோம், நல்லா ஸ்ட்ராங்கா இருக்கும்னு நினைச்சிட்டு போனா, then we conducted the field test and it was not capable of even supporting 10 ton per square meter. Then they had to redesign the whole building. We had to think of some improvement also. We did some improvement also in the sandy layer. So likewise, I can keep on, and expansive soil. The last one is expansive soil. You can see many buildings which have cracked in all possible ways. I can tell examples after examples for this. I still remember in one of the building which was a textile mill those days, that owner bought that land at a cheaper price. But when he started doing the construction, by the time he crosses the plinth level, there were cracks in the building. அவர் plinth level கொஞ்சம் மேல வர்றதுக்குள்ள கட்டடம் அங்கங்க கிராக் ஆக ஆரம்பிச்சிருச்சு. அவ்வளவு கிராக். We were called to analyze it. And we found that soil is highly expansive soil. But அந்த பில்டிங்கோட ஓனர் வந்து அப்போ he was a leading politician. I don't want to tell his name. He was a sitting minister at that time. அதுல பியூட்டி என்னன்னா அவர் சொல்றாரு, எங்க ஊர்ல எல்லாம் நான் தாங்க இன்ஜினியர், எல்லா கட்டடத்தையும் நான் பார்த்து தான் நான் பண்ணுவேன். என்னோட ஓன், அவங்க சன்னிலாவுக்கு வாங்கி கொடுத்த பில்டிங் இது, என்னோட ஓன் இதுல நான் மிஸ் பண்ணிட்டேனே அப்படின்னு பேசிட்டு இருக்கப்போ அவர் சொல்றாரு ஒரு சின்ன, he narrated a small story. சார் நான் கட்டடம் கட்டுறதுனால ஒரு தொட்டி கட்டினேன் சார். சந்தோஷம். இந்த தொட்டி கட்டி ஒரு 2 நாள் தொட்டி கிராக் ஆயிடுச்சு சார். ஓகே, அப்புறம் என்ன பண்ணேன், தொட்டியெல்லாம் ரிப்பேர் பண்ணேன். ஒன்ன கொத்திட்டு காங்கிரீட்டு இதெல்லாம் வச்சு நான் ரிப்பேர் பண்ணேன் சார். ஓகே சார், அதுவும் நிக்கல சார். அதுக்கப்புறம் நான் ஸ்மால் காங்கிரீட் பீம்ஸ் இல்லைன்னா கம்பியை வளைச்சு அப்படி பேனா ஷேப்ல வளைச்சு உள்ள இன்சர்ட் பண்ணி எல்லாம் ஸ்ட்ராங்கா ரெக்டிஃபை பண்ணேன் சார். அப்பவும் நிக்கல சார். அப்புறம் என்ன சார் பண்ணீங்க, கடைசியா ஒரு தார்பாலின் வாங்கி தொட்டிகளை போட்டு தண்ணியை ஊத்திட்டேன் சார். தார்பாலின் தான் இப்ப தொட்டியா நின்றுகிட்டு இருக்கு. அந்த ஷேப் இஸ் மெயின்டைன் பை த தொட்டினர். I asked him only one question. சார் இவ்வளவு சிம்டம்ஸ் உங்களுக்கு கிடைச்சிருக்கு, ஒரு தொட்டியே நிக்க மாட்டேங்குது, அவ்வளவு கிராக் ஆயிருக்கு, பட் டிட் யூ நாட் திங்க் there is something problem with the soil? அப்பதான் அவர் சொன்னாரு, அப்படி நான் திங்க் பண்ணவே இல்லை சார். நான் ஃபவுண்டேஷன் போட்ட அப்புறம் பிளிம்ல இருந்து எல்லாமே கிராக் ஆக ஆரம்பிச்சிருச்சு. ஸோ இது நான் ஒரு சின்ன இந்த ஸ்டோரியில இருந்து there are lot of informations available, lots of information available. சாயில்னால ஒரு பில்டிங்ல ப்ராப்ளம் வந்துச்சுன்னா எந்த ரெக்டிஃபிகேஷன் பண்ணாலும் நீங்க அதை அரெஸ்ட் பண்ணவே முடியாது, unless you treat the soil. That is very very important. And another thing அவர் ரொம்ப பியூட்டிஃபுல்லா சொன்னார், நான் ஒரு தார்பாலினை போட்டு உள்ள மூடிட்டேனார். இன்னைக்கு ஜியோடெக்ஸ்டைல்ஸ்னு ஒன்று கேள்விப்பட்டிருப்பீங்க. ஸ்டூடெண்ட்ஸ், யூ கேன் கூகுள் அவுட் அண்ட் சி ஜியோசிந்தெட்டிக் மெட்டீரியல்ஸ். That is playing a wonderful role in all infrastructure projects. Don't think of residential building, ஒரு மாடி கட்டடம், 2 மாடி கட்டடம், 3 மாடி கட்டடம். Think big. அவ்வளவு ஒரு infrastructure projectsலயும் the role of this geosynthetic material is there. Probably you can see one of the dams nearby Heidelberg projects, Kadambari Dam. There was seepage, leakage everywhere. You know, finally what did they do? They covered the entire dam with the geosynthetic material. Finished. So the tarpaulin சொன்னது, இன்னைக்கு variety of geosynthetic products are there that is being implemented. That is why I'm just telling, civil engineering is an ocean. Civil engineering is an ocean. But once I got in touch with this geotechnical engineering, I still have a feeling even geotechnical engineering is an ocean. So much of areas, probably if I get an opportunity, I can project. Now I am just concentrating on the fundamentals of what is needed. And I am sure only when you are strong in the fundamentals, then probably you can go beyond that. So probably I was just still giving the introduction of it. And probably if you just see, come below about the fields, let me not touch that, because in the Southeast Asian countries like Singapore, Malaysia, Brunei and all, you can see there will be a lot of reclaimed field. You can see under the uncontrolled field, reclaimed field is there. Soil is reclaimed from water being used for buildings. Then solid waste. Below that you can have a look at the solid waste. Solid waste is now everywhere. We are dumping solid waste anywhere you find. There is no house construction, there is an empty site, you dump the solid waste. What is the main problem with the solid waste? You can just see here, high compressibility, What is that high compressibility? It will settle as you keep on loading it over it. So if it is highly compressible, the settlement will be high. The settlement is high, it leads to a lot of problems that I am going to discuss now. So friends, probably I have taken so much of time to give an introduction to you. Now, if time in the introduction I spend, you should be able to think and you should be able to develop an interest towards these subjects in this topic. And once you develop interests, then probably you can understand what it is. Normally, a lecture goes beyond 20 minutes. It's not advisable. But we already gone nearly 40 to 45 minutes. But there is no other way for us, because we have to do everything in online. And why these 20 minutes? The mind can concentrate only up to that time. Still, we are compelled to go beyond that time limit also, because as in a webinar, probably we must be able to spend more time to explain these topics. Next. Now, the first question is, what is safe bearing capacity? I told you all the loads are transmitted to the soil. Simple safe bearing capacity ஒரு பர்டிகுலர் சாயில் என்ன லோடு தாங்கணும்ன்றதா வேற ஒண்ணுமே கிடையாது. இந்த சாயில்ல எவ்வளவு லோடு அப்ளை பண்ணா அது சேஃபா இருக்கும். இன்னொரு சாயில்ல நீங்க ரெண்டு எக்ஸ்ட்ரீம் கண்டிஷன் பாருங்க. ஒரு ராக் எடுங்க, ஒரு ராக்ல எவ்வளவு லோடு அப்ளை பண்ணா உங்களால பிக்கா சொல்லிட முடியும். சார் இது நல்லா ஸ்ட்ராங்கா இருக்கும் சார், நல்லா ஸ்ட்ராங்கா நல்லா தாங்கும்னு சொல்லலாம் ராக்ல. வேற ஒரு சாயில்னு சொன்னா யூ கேனாட் கிவ் a direct answer. நல்லா ஸ்ட்ராங்கா இருக்கும்னு சொல்ல முடியுமா? சொல்ல முடியாது. ஒருவேளை அதனோட ஃபார்மேஷன் இஸ் ஹார்டுனா சார் கொஞ்சம் ஸ்ட்ராங்கா இருக்குன்னு சொல்லலாம், அப்படின்னு சொல்லலாம். பட் நமக்கு இது ஸ்ட்ராங்கா இருக்கா இல்லையான்றது மட்டும் முக்கியம் இல்லை. வாட் இஸ் தி லோட் தட் கேன் பி சேஃப்லி அப்ளைடு? Can you apply 100 kilometers per square meter or 200 or 300 or 400? Nowadays, because I am in the field, even if I give a recommendation of 300 kilometers per square meter, the consultant will ask, sir, can we make it as 400, sir? நான் இப்பதான் உங்களுக்கு சொன்னேன், நாங்க 300 கொடுத்தா கூட 100 தான் எடுப்பேன்னு எடுத்த காலம் போய் இப்போ நாங்க 300 கொடுத்தா கூட சார் இன்னொரு 100 சேர்த்து கொடுக்க முடியுமா பாருங்க சார் கொஞ்சம். அதுக்காக நம்ம சும்மா கொடுக்க முடியாது. But we'll see, because in all these things, particularly in soil, it's not like structures where the factor of safety even you can take in steel 1:1 or 1.5, 1.15. Whereas here it is recommended, the code itself says the factor of safety can range from 2 to 3. 2 எடுக்கலாம், 2.5 எடுக்கலாம், 3 எடுக்கலாம். நான் 3 எடுத்து ஒரு வேல்யூ கொடுத்துருக்கலாம். Suppose if you need more value, I can reduce the factor of safety. But I will not simply reduce it. If I am satisfied with the way of investigation part of it, if I do a thorough investigation, then I can give you a more value. The value can be slightly increased also. So here I have highlighted 2 points. One is a shear failure, another one is a settlement failure. And the safe application, it is governed by shear failure and settlement failure. Now you may ask me a question, sir, what is a shear failure? We'll see that. So what is a shear failure? You can understand what is a shearing. நம்ம ஸ்ட்ரெஸ்ஸஸ்ல பார்த்துருக்கோம். Tensile failure, compression failure, shear failure. You can just see shearing. So this shearing is taking place below the foundation in the soil. There are 3 types. So one more thing I just want to stress here. In all other building materials, whether it is cement, whether it is concrete, whether it is tile, whether it is brick, codes are pakka And whatever codes I've specified can be followed 100% in total. Whereas in soil, codes are meant to give you only the guidelines. They can only guide you. Do like that. Do like that. You may also deviate from that to reduce the value and also to increase the value. That's why I quoted basic. And general shear failure, local shear failure, punching shear. There are three types of failures. Because in the definition we had given shear and settlement. So I am just concentrating on the shear. Shear, I have just put three conditions: general shear failure, local shear failure, and punching shear. What is general shear failure? Suppose I have just put Q ultimate. That is the footing. Imagine that to be the footing. No footing na step mari step kanon pakadinga. It is for a strip footing, and it looks like that. Now below that, if you just are you able to see the pictures? Can I get response from any one of you? No. Is it audible? Hello? Is it audible? எல்லாம் மியூட்ல அன்மியூட்ல இருக்கு.
இல்ல அவங்க அன்மியூட் பண்ணி பேசிக்கலாம்.
பேசிக்கலாமா?
ஆமா. யாரா தெரியுமா?
Professor Muthupriya, are you there? Okay. So in the case of the general shear failure, just see here, the footing is pushed downwards and there is a pattern of failure plane. But if you ask me, sir, whether this pattern will be visible below the footing, to your naked eye, it may not be visible. But we have shown a small heave close to the footing above the ground, and that is visible in the case of the general shear failure. And there is a load settlement curve. You can just have a look at the pattern of the load settlement curve. So there are three regions of failure: 1, 2, and 3. 3 shear zones are developed, and such type of failure occurs when the phi value is greater than 36 degrees. What is phi? Phi is nothing but your angle of shearing resistance or angle of internal friction. When it is greater than 36 degrees, I don't say that you should check the phi value of that. And if it is a dense sand, the phi value is greater than 36, it looks like that, general shear failure. In what way this is helpful to me? I can understand the shear strength is fully mobilized. Failure occur ஆகுதுன்னா இதுல இருக்கக்கூடிய எல்லா லைன்ஸும் டெவலப் ஆயிருக்கணும் below the footing. ஆனா நீங்க போய் பாத்தீங்கன்னா இருக்காது. Next one is your local shear failure. Local shear failure பாத்தீங்கன்னா இங்க பாத்தீங்கன்னா ஒரு dotted line இருக்கு in the shear zones, first row, second, third, அந்த ஒரு spiral curve மாதிரி போற இடத்துல there is a dotted line. And the surface heave close to the footing is also not, the surface heave is also limited, and practically there may not be any surface heave also. Here, if you just look at the phi value is less than 30 degrees. Normally phi and C are the shear strength parameters. Phi and C are the shear strength parameters. So phi value, let us not check panna vendiyadilla. We need not check phi value enna irukku nu paaka vendiyadhu. We can understand if it is a soil which has got a phi value less than 30, there is a local shear failure. In what way it helps? I told you in the previous case, the shear strength is fully mobilized in Cholrana. Local shear failure, only 2/3 is mobilized. By the time 2/3 is mobilized, it fails. By the time 2/3 is mobilized, it fails. நான் நார்மலா ஸ்டூடெண்ட்ஸ்ட சொல்றப்போ இதை வந்து டக் ஆஃப் வாரோட கனெக்ட் பண்ணி சொல்லுவேன். ஒரு டக் ஆஃப் வார் போட்டி உங்களுக்கு தெரியும், கயிறு இழுக்கும் போட்டி. 2 சைடு இருந்து நல்லா இழுத்துட்டு இருக்கிறீங்க, எல்லாருமே ஃபுல் பொட்டன்ஷியல் கொடுத்து இழுக்கிறோம், அப்புறம் ஒரு சைடு இழுத்துறோம். பட் லோக்கல் ஷியர் ஃபெயில்ன்றது இந்த சைடு நிற்கிற 10 பேர்ல ஒருத்தன் திடீர்னு இடறி கீழே விழுந்துட்டாங்கன்னு வச்சுக்கோ, தென் ஆல் ஆஃப் அ சடன் there is a failure local. எல்லாரும் அவங்களோட ஃபுல் ஸ்ட்ரென்த் மொபிலைஸ் பண்றதுக்குள்ள இந்த ஒரு ஆள் ஸ்லிப் ஆயிடுறாரு, ஆட்டோமேட்டிக்கா it will be pushed to this side. So there is a local failure, local before it is fully mobilized. Even the material testing also, if there is a small cavity, the full shear strength may not be obtained. So that is, there is some local failure is there. So the value will be less. That is what you need to understand. Then the other one is your punching shear failure. Punching shear failure. Punching na theriyum, punching machine பார்த்திருக்கோம். பஞ்ச் பண்ணா என்ன ஆகுது, அப்படியே கட் ஆயிடும். அதுதான் இங்க அப்படியே பஞ்ச் ஆன மாதிரி அப்படியே ஃபுட்டிங் கீழே போயிட்டு. நான் சொன்னேன் உங்களுக்கு ஒரு எக்ஸாம்பிள் சொன்னேன், குன்னூர்ல ஒரு யூத் ஹாஸ்டல் ஒரு பில்டிங் வந்து அப்படியே செட்டில் ஆகி போயிட்டு இருந்தது. 2 அடி 4 அடி செட்டில் ஆயிடும். 4 feet it had settled. 4 feet is about 1.25 meter. அது என்ன, இந்த பேட்டர்ன் இஸ் பஞ்சிங், அப்படியே பஞ்சாகி போயிட்டே இருக்கு. இன்னும் கொஞ்சம் லோடு ஏற்றணும்னா இன்னும் கீழே போயிட்டே இருக்கு. ஸோ திஸ் இஸ் வாட் பஞ்சிங் ஷியர் ஃபெயில்யூர். அந்த பஞ்சிங் ஷியர் ஃபெயில்யூர்ல பாத்தீங்கன்னா எந்த விதமான சைடு ஹீவ் இருக்காது. The base sinks into the soil like a punch. So that is what you need to understand. So okay, next one. So there are 3 types of shear failures. We have to see the shear failure also, and this I have just explained. And probably for the students, this is very important from their examination point of view also, because after all, students need to score marks in their examination. So it's an important area where questions will be asked. So that will be the thing. Then next is our settlement. Probably if you go back to this settlement failure, which is highlighted in blue color, next is our settlement failure. What is that settlement failure? Illa shear alla fail ana mattum pattava. Why settlement failure is also to be considered. Probably in a definition pathina, settlement is the downward movement of the ground caused by load displacing the soil. ஒரு அந்த டாக்டர்ல காட்டியிருக்கிறது வந்து இட் இஸ் a settlement. இந்த செட்டில்மெண்ட்ல வந்து 2 டைப் ஆஃப் செட்டில்மெண்ட். ஒன் இஸ் யூனிஃபார்ம் செட்டில்மெண்ட், another இஸ் டிஃபரன்ஷியல் செட்டில்மெண்ட். அது என்ன யூனிஃபார்ம் செட்டில்மெண்ட்? நான் இப்போதான் உங்களுக்கு ஒரு எக்ஸாம்பிள் சொல்லி முடிச்சேன். குன்னூர்ல வந்து ஒரு பில்டிங் அப்படியே யூனிஃபார்மா செட்டில் ஆயிட்டு. There was no crack in the building, not even a small crack in the building. Uniform settlement. Then what is the differential settlement? Suppose you take 2 columns. One column settles by 5 centimeter, another column settles by 10 centimeter. There is difference in settlement between these 2 columns. The beam that is supported by these 2 columns will be subjected to 2 different strains, and that causes twisting or moment in the beam section, beam cracks. So for us, the uniform settlement may not cause any crack in the building, whereas differential settlement will definitely cause cracks in the buildings. Probably as engineers and builders, நீங்கெல்லாம் நிறைய கிராக்ஸை பார்த்துருக்கலாம் கட்டுறதுல, காம்பவுண்ட் வால்ல. இந்த கிராக் டியூ டு சாயில வந்து பார்த்த உடனே தெரிஞ்சிடும். நான் நிறைய ப்ராஜெக்ட்ஸ் இன்ஸ்பெக்ட் பண்றப்போ we have seen, sir, இந்த கிராக் எல்லாம் நாங்க ரெக்டிஃபை பண்ணவே முடியாது unless we treat the soil. So the differential settlementனால. But one more point that you should understand, the uniform settlement வந்து ஒரு லிமிட்டிங் வேல்யூக்கு மேல போச்சுனாலே that will result in differential settlements. So that probably we'll see in the subsequent slides. Uniform settlement. Of course, இதுல beautiful ஒரு சின்ன residential building காட்டுறோம். Settle ஆயிருக்கு. Dotted line was the original இப்போ இது. Then it has come down. கீழே காட்டியிருக்கிறோம். நீங்க பாருங்க ஏதாவது crack ஆயிருக்கான்னு பாருங்க. ஒண்ணும், there is no crack in the building. So when a building foundation settles by the same amount over its entire footprint area, and the southeast corner என்ன செட்டில் ஆயிருக்கோ அதான் நார்த் வெஸ்ட் கார்னர். ஸோ இப்படி யூனிஃபார்மா செட்டில் ஆகிறது தான் we call it as immediate settlements. How do we calculate that immediate settlements? இதுல we can just see here in the uniform settlements, there are two settlements I have mentioned. One is immediate settlement, another one is consolidation settlements. Two components are involved. So we have to calculate these two settlements separately, then add to that, and you should not exceed a particular value of settlements. And suppose next slide you see immediate settlements. How do we calculate the immediate settlements? நார்மலா சாண்ட் இருந்துச்சுன்னா நீங்க ரொம்ப பயப்பட வேண்டியதில்லை. கட்டடம் கட்டி முடிச்ச உடனே என்ன செட்டில் ஆகுதோ அதான் ஃபைனலா அது வரைக்கும் அந்த செட்டில்மெண்ட் இருக்கும். தட் இஸ் இம்மீடியட் செட்டில்மெண்ட். ஸோ சாண்ட் வந்து கட்டி முடிச்சு 2 வருஷம் கழிச்சு இன்னும் செட்டில் ஆகாது, அன்லெஸ் தெர் ஆர் சம் எக்ஸ்டர்னல் டிஸ்டர்பன்சஸ். வேற கிளே எடுத்தீங்கன்னா அதுல இம்மீடியட் செட்டில்மெண்ட் ரொம்ப கம்மியா இருக்கும். And time excuse me, time dependent settlement சொல்லுவோம். இது செட்டில் ஆயிட்டே இருக்கும். 1 வருஷம் ஆனாலும் செட்டில் ஆகும், 2 வருஷம் ஆனாலும் செட்டில் ஆகும். ஸோ கிளேயை பொறுத்தளவுல that settlement is called as the consolidation settlement. So immediate, now இது just out of academic interest I have shown it here. Immediate settlement is equal to Q naught. So that is the bearing capacity, safe bearing capacity. B is the breadth of the foundation. Mu is your Poisson's ratio, and E suffix is your elastic modulus, and IS and IF are the influence factors. So this settlement can be calculated. This is for the purpose of the students. They can see how the immediate settlement can be calculated. The second settlement is consolidation settlement. And it is a time-dependent settlement. In the consolidation settlement, you can see S suffix C, settlement due to consolidation is equal to H naught divided by 1 plus E naught. CC log to the base 10 into sigma 0 dash plus delta sigma divided by sigma 0. This will occur in the case of clay soil, and this consolidation settlement will be occurring over a period of years. இன்னைக்கு முடிஞ்சிரும் நாளைக்கு முடிஞ்சிரும்னு கிடையாது. எவ்ரி இயர் அது செட்டில் ஆயிடும். இந்த கன்சாலிடேஷன் செட்டில்மெண்ட் நம்ம எப்படி கண்டுபிடிக்கிறதுனா, there is a calculation here, and E naught your void ratio, H naught is the thickness of the sample, and we have to conduct a consolidation test in the laboratory. Consolidation test in the laboratory. That's what I mentioned in the beginning. சாயில்ல டெஸ்ட் பண்ணோம்னா மாய்ஸ்சர் கண்டென்ட்க்கு ஒரு 24 hours ஆகுதுன்னா கன்சாலிடேஷன் செட்டில்மெண்ட்க்கு வந்து 3 days 4 days ஆகும், depending on the loading conditions. How many people do the consolidation test? I do not. But in the case of the clay soils, the consolidation settlement has to be determined, based on which your bearing capacity value can be given. I have just mentioned to you, we can give 30 ton per square meter, or 40 ton per square meter, or 20 ton per square meter. And it is in one way based on some arithmetic calculations, or based on some field tests. But this consolidation test will give us the confidence to give the correct value of bearing capacity, safe bearing capacity. That is very, very important. Simple calculation is not correct. That arithmetical calculation combined with this consolidation settlement, particularly in the case of the clay soil, is very, very important before we come to the conclusion on the clay soil. SBC. So the consolidation settlement, there are two types. One is a primary consolidation settlement, secondary consolidation settlement. Primary consolidation settlement can be determined from the consolidation test, whereas secondary consolidation settlement cannot be determined easily, and it occurs for 5 years, 6 years also. And normally this secondary consolidation can be ignored. So I just please forget about the secondary consolidation. So in the case of the primary consolidation settlement, what happens? Or soil settle aganumnale, if the soil has to settle down, the void should be reduced. Void should be reduced. Voids probably romba colloquial solradha irundha, the gap between the particles, soil particles or soil solids, that is voids. The settlement is possible under two situations. One is, and the voids it contains two components. One is air, another one is water. Sometimes voids are filled with air completely. Then we call that soil as a dry soil. If it is a dry soil, the voids are filled with only air. And sometimes the soil is completely saturated with water. You know, water table nama paakrom. Water table definition, it is nothing but the top surface of the saturated zone of the soil. That means adukku keela irukka soil ellame saturated ah irukum. Adu keela irukka ellame saturated ah irukum. What is that saturation? All the voids are filled with water. All the voids are filled with water. So, ipo consolidation settlement occur avanuna, the voids kureyanum, voids la irukkudiya air veliye ponum, voids la irukkudiya water veliye ponum. The air veliye poradhukku oru method. Adudha compaction sollu. Orvela students may be familiar with standard Proctor compaction test. And all engineers and builders may be familiar with the road rollers, compact equipments. So either the equipments which compact pandrapo, air voids is reduced. Air voids is reduced. Whereas clay soil, the reduction is mainly possible with the dissipation of water from the voids. Voids water veliye. If I mention about stone column, sand drains, PVDs, infrastructure projects, these are all very common. Load will be heavy, underlying soil will be very soft, and the soil have to be strengthened. Ground improvement techniques, that has got a lot of scope. Ground improvement techniques, normally, previously I used to ask, if I want a concrete of M60 concrete, I can immediately make it. But can we make a soil of M16 gata? But with the advancement in the ground improvement techniques, we can also say it is possible. The existing ground, existing soil can be improved upon by these ground improvement techniques, even to take care of 60 tons per square meter also. So please remember, I just concentrated on two factors. One is the shear, another one is the settlement. That is why I have gone deep into these two aspects, because we should know how the bearing capacity is calculated, how the bearing capacity is evaluated. So then differential settlement. Differential settlement is a chinna figure kaatiruken. The mari pattern of cracks. If நிறைய buildings நீங்க பார்க்கலாம், road பார்க்கலாம், walls பார்க்கலாம், compound walls பார்க்கலாம். And you see, every structure is designed for a limiting settlement, tolerable settlement. Or isolated footing, sand rest pannona, the tolerable settlement is 25 millimeter. For the same isolated footing on a clay soil, it is going to be 40 millimeter. If it is a combined footing, the permissible settlement, if it is on sand, is 40 millimeter. Same if it is on clay, it is going to be 65 millimeter. And if it is a rack foundation, the sand on sand will be 65 millimeter, clay will be 100 millimeter. So we design the building, we evaluate the bearing capacity, taking these values into consideration, that for raft, we have a permissible settlement of so much. Isolated footing, we have a permissible settlement of so much. And if you exceed the settlement, exceed this uniform settlement, that may lead to differential settlement in buildings. That is what we need to remember. So these are all some of the things, uniform settlement, building a tipping settlement, with the differential settlement, every crack are going just for. So this is what. Okay. So these are all some. See how walls are cracked. There are a lot of projections. So the bearing capacity, I have a definition. There 2 aspects are stressed. One is the shear failure, another one was the settlement failure. So that you need to remember. Your bearing capacity, field there are methods. Standard penetration test, dynamic cone penetration test, plate load test. And there are analytical methods. There are many more methods also available. I am not just bringing it here because let it be at the preliminary level so that I just don't want to go beyond that at this stage. And standard penetration is very common and it is universally accepted all over the world. The output of the standard penetration test in Batikana simply a capital N, SPT N value. In the country, the N value of the soil is so much in Jona, they can easily understand, okay, this will be the property of the soil. This will be the condition of it. So next one is dynamic cone penetration tests. So when there you come across gravelly soil, there will be a code because in the standard penetration test being conducted in a gravelly soil will be a bit difficult. Whereas in dynamic cone penetration test, that is possible. The another one is the plate load test. Probably in Coimbatore, you can see now almost for all infrastructure projects, for bridges and all, they conduct it as a pile load test. So pile load test is nothing but a plate load test, but it is tested on a pile. You see huge cartilage and surcharge in the form of sandbags arranged and all this. And there are analytical methods. And Tetsahi, probably students will be interested. Tetsahi is the father of soil mechanics. It is only who has developed all the theories in the soil mechanics. And there is an IS code method also available. So that is what you need to know. So we'll just quickly go into that. So standard penetration test in brother, we just make a pit. So this is a simple test. And probably the cost for this test is considered to be minimum. That's what I can say. And depends, if it is a small building, and if you thoroughly know about the substratum of soil, we can go for the standard penetration test, for which we make a pit. Normally, we make a pit of 1.5 meter by 1.5 meter up to the desired level of foundation. Our foundation enna level of போடணும்னு நினைக்கிறோமோ அந்த லெவல் வரைக்கும் போடலாம். So I just demonstrate what is a standard penetration test. Just have a quick look at it. So this is the test setup, a tripod, and there is a pulley tied with the rope, and probably there is weight. I will show it in the next slide. You can just see here. So there is a weight tied by a chain, which is in the horizontal direction on the ground, which is lying on the ground, and that solid block, that is the weight, that weigh about 65 kilogram. And you see it will be allowed to fall over a height of 75 centimeter, and the person is holding a steel rod like thing that is called as the split spoon sampler. There is a standard sampler as specified in the IS code. And even British code also the same dimensions they have. So also in the American code. So that is why n value is standard throughout. That's why I told you. And now you see here how the test is being conducted. Just to see the test setup. At bottom, the larger diameter is your weight. So through this pulley and the rope, this weight will be lifted. And all of a sudden, it will be dropped. You should not slowly drop it. You should withdraw your hand. Suddenly, it will be dropped. It will apply a blow onto the head. So the head will drive the split spoon sampler. I am yet to show you the split spoon sampler. So this is what this split spoon sampler. You can just see here the standard dimension. And at the top, if you just look at, there is a cutting edge here. There is a so there is a cutting edge here. This is cutting edge. There is a swivel head here. And there is a small hole here at the part of it. And that is for the air to escape when you drive the spoon sampler inside. And this middle portion, this can be separated, screw type. This is separated here. This can also be separated, this also separated. And this portion is split into two. That is why it is called as the split spoon sampler. You see here, the sectional view is given here. What are the dimensions given? So here, what we do in this test, probably this is another, this is the weight, this is the driving head, 75 centimeter height of fall from here to here. This is the split spoon sampler. What is that we do? See here, we observe the number of blows that are needed for the penetration of the sampler for 15 centimeter. The 6 inches that is 15 centimeter. Similarly, 3 such 15 centimeters, the number of blows required for each 15 centimeter 3 times. So first 15, second 15, third 15. We consider the first 15 as a seating drive. Normally, pit excavate pandrom. Maybe pit is open for the atmospheric conditions. Weathering. So initially it is called as a seating drive. So now, when that is a seating drive, what is that N value? What is that SPT N value? The SPT N value is nothing but the number of blows required for the penetration of the last 215 centimeter. First 15 centimeter seating drive. Ignore these 6 blows. For second, it is 10. For the third, it is 22. Now the N value is 32. So that is what. And this is an observed N value. And for this N value, there are corrections in the field. The first correction is dilatancy correction. Dilatancy correction will be applied when we conduct the test in a saturated silty sand. See, every terminology has a meaning. Saturated. Just now I told you what is meant by saturated. All voids are filled with water. So when it is saturated, the water that is present in the voids is called as the pore water. This pore water will offer some resistance to the penetration of the blows. So there will be an apparent increase in the number of blows. So the number of blows observed is more than the actual blows that are needed because of the saturation of the soil. So when it exceeds, the observed N value is greater than 15. In our case, the observed N value is 32. Now it is greater than 15. Now I have to apply a dilatancy correction. What is the dilatancy correction? 15 plus 0.5 into N dash minus 15. We had observed it as 32. So 15 plus 0.5 into 32 minus 15. So 30 minus 15 is 17. Half of 17 is 8.5, or you can take it as 8. So 15 plus 8 is 23. This 23 is the corrected SPT N value. Observed SPT N value is 32. That is now corrected to 23. Just imagine. Because it is overestimated because of the presence of poor water pressure. So now that corrected N value has to be applied in another overburden correction. What is an overburden correction? Just if you go to that pit, see, we conduct this test in a pit, the open pit. So before the pit was excavated, just imagine, this is the pit. So we removed the overburden above this bottom of the pit. As a result, now this split spoon sampler can easily penetrate into the soil, or the penetration value is underestimated. We don't remove the soil anywhere. If you now dry the split spoon sampler without removing any soil, there will be an overburden pressure. That surcharge will make this bottom of the pit still compact, and the split spoon sampler will find it go easily. Since the surcharge is removed or overburden is removed, we just go for the application of the overburden correction. So after this correction is also applied, here of course N dash is the observed N value, 350 divided by sigma dash and chalo, let me not, sigma dash is nothing but the effective overburden pressure. So effective overburden pressure is nothing but sigma is equal to gamma into H, that's all. What is gamma? Gamma is nothing but the unit weight of the soil. So unit weight of the soil multiplied by the height is giving you the. So this is a very handy test. If you just want to read the procedure, you can go through that, or you can go through that later also, because it's available in the code, it is available in the book, and this is what the procedure, how it is done. So now I told you this is universally accepted because weight is the same, height of fall is, that is the energy applied on the split spoon sampler is the same, and dimensions of this split spoon sampler is the same. So naturally everyone has to accept it is standardized. Now once the N value is corrected, from this N value only we calculate what is the bearing capacity of the soil. I told you the bearing capacity is based on two factors. One is the shear failure, another one is the settlement failure. So there are two formulas available here. One is based on shear failure, another one is based on the settlement concentration. So this is only an arithmetic formula. You see here, N is the corrected N value, B is the breadth of the foundation, RW is the water table correction, and N is again the N value, DF is the depth of foundation, and RW1 is the water table correction. So what is this water table correction? In a sandy soil, the presence of water or the water table rises up to the foundation level. The water table rises up to the ground level. The bearing capacity will be reduced by 50%. The soil is capable of having a bearing capacity of 500 kilonewton per square meter. It is reduced by 50%. Actual capability is only 250 kilonewton per square meter. So the water table correction has to be applied in all, because when we construct it may be dry, but when will it be saturated we do not know. And in certain conditions the groundwater table itself may be rising up to the ground level, and in certain conditions due to flooding the entire area may be saturated. Because of saturation the column may sink in. So in all calculations we consider the water table reduction factors also. The second one is based on settlement. So to see here, this is the N value, this is the breadth of the foundation, this is a reduction factor, and this is RW1 is the water table reduction factor. The S which is shown in the red color is the limiting settlement. I discussed for an isolated footing on a sandy soil, it should be 25 millimeter. For an isolated footing on a clay soil, it could be 40 millimeter. So I can now calculate a value based on the settlement. So that is important. Invariably, the safe bearing capacity calculated based on the limiting settlement will be the governing value. Governing value is another. Suppose shear failure வந்து உங்களுக்கு 1000 kilonewton per square meter கிடைக்குதுன்னா the settlement considerationல அது 300 kilonewton per square meter தான் கிடைக்கும். எப்பவுமே இதுதான் கம்மியா இருக்கும், இதுதான் governing, இதைதான் நம்ம என்ன பண்ணணும் எடுத்துக்கணும். So that is what. And the shear failure, this is only ultimate, it is actually Q ultimate divided by a factor of safety. As I told you, factor of safety can range from 2 to 3. 2 எடுக்கலாம், 3 எடுக்கலாம், 2. This is where the experts will have to play a role. This is very, very important. Investigation, I told you, everybody is afraid of the money. ஒருத்தர் 5,000 சொல்றாரு, ஒருத்தர் 10,000 சொல்றாரு, ஒருத்தர் 15,000 சொல்றாருன்னா நீங்க அதுல யாரு ரொம்ப குறைச்சு சொல்றாங்கன்னு சொல்லி அவங்ககிட்ட போய் அந்த பேரிங் கெப்பாசிட்டியை கரெக்டா அசஸ் பண்ண முடியலன்னா you will be losing lot of money on your foundation. Expertise is very, very important in assessing it. Though there are some empirical relationship. So though N-value can be conducted by an SPT test, but the higher value can also be given, lower value can also be given based on the factor of safety, based on the satisfaction in the investigation, based on the consolidation. There are so many factors. It is not simply just a test and giving a value. This everyone should remember. And many people used to ask immediately after the test is over, so what is the SBC that we can adopt? If it is a gravelly soil, I can straight away tell sometimes. If it is a clay soil, fine soil, not easy to share. As I told you, we have to conduct the consolidation test. We have to conduct the consolidation test also. So this is one. Probably we are running out of time. That I just see. And once the SPT is there, this gives an idea about the various parameters of the soil also. This is after conducting extensive experiments. This is given by Mayer. So for N value, we can classify what is the state of packing. I just quickly go to the another test which is called as the dynamic cone penetration test. The test procedure is the same, the test setup is the same, but the only thing at the bottom of it you can see there is a cone. Instead of the split pone sampler that I had shown earlier, this is a cone here. This cone will facilitate piercing into the gravelly soil. That is important. There we calculated the penetration for every 15 centimeter. Here we are going to calculate it for every 10 centimeter. 10 centimeter, 10 centimeter, 10 centimeter. And another advantage of this is, there in the split pone sampler, the soil will, there is a hollow portion at the middle of the split pone sampler. Soil will get into the split pone sampler and 45 centimeter finished. Then you have to remove it. Then you conduct another test. But here, the DCPT test can be conducted continuously for any depth. You need not remove it and conduct it. You can continuously observe. Then that will give you an idea what is the penetration resistance across a particular depth. Probably you can see it. Of course, this is the cone. This cone is also standardized, dynamic cone. This is also universally accepted one. And this is the observation that you make. And on this side, you can see have the depth in meter. I have continuously gone up to a depth of 12 meter or 13.5 meter. Just imagine. So this is the graph. This shows the penetration of the soil. And this is okay for me to decide about. See here, at a depth of 1.75 meter, this is very high. But just below that, it is less. Can we take this as the depth of foundation? Can we take this value for the safe bearing capacity? No, because there is another criteria. To what depth this influence of this load will be there? what depth the influence will be there. If it goes like this, even a straight line, I can choose this value. Even if it doesn't increase, but goes like this, I can still choose, but it is declining. And for every foundation, the influence will be there for about 1.5 times or even 2 times the breadth of the foundation. If the width of the foundation is 2 meters, below the base of the footing, another 3 to 4 meters, I have to see the same soil continues. The same stiffness of the soil continues. If it is not there, then the failure will take place. So this gives a clear history about it. So this also we have been doing. And dynamic, this what. And there is a correlation between the cone resistance and the N value. And now the N value can be obtained from the cone resistance value. And this obtained N value can be substituted in the arithmetic formula, which we show for the calculation of the bearing capacity of the soil. So this is what depth of exploration. See here, if this is the base of the footing, there are 3 conditions for that. 1, 2, 3. But instead of understanding all these 3, we simply say 1.5 times or even 2 times from the base of the footing. Why I say even 2 times? In the code, some values are given, but we can never take it as a final, because if one suspect that it has to be checked even below that, it has to be checked. Because the codal provision is only a guideline. It's not a final value, final guideline. So that is why I said 1.5 to 2 times. And it is not confident. Just see here, 1.5 times B from the rafts. Suppose you provide a raft, entire width, maybe about 10 meters, 20 meters, then what should you do? You should explore up to 20 meters. Then. Are we doing that? Are we doing that? And spacing of the borehole. There is a number of boreholes needed. எத்தனை பிட்டு போடணும், எத்தனை போர் போடணும். இதெல்லாம் வந்து very difficult to convince the clients, convince the engineers. Very difficult. Suppose if I say 2 pits we have to see, sir, can you not do it with only 1 pit? For this 1 pit, I am going to tell you a story if I find time before I conclude. Whether it is 2 pit or 1 pit or number of those required, I just end up with a small story. Then you will understand that you will give a freedom. Because I always compare this with the doctor profession. Suppose you take a blood my body. Can you go to any experienced doctor and ask him straight away, sir, this is my blood. Can you tell me which group it belongs to? Can anybody say? Test, we tested. And doctor says this blood test is not sufficient. Go for a scan. Do you think that he is telling for a joke? He is not convinced. He is not able to come to a conclusion of the blood test. He wants a scan so that he will be able to find out. Why do you go to for a second opinion? Why do you go to an experienced doctor so that he can easily identify? Many times, you have come across an X-ray. Suppose it is projected before you and me, it look like a figure. But for an experienced doctor, where is the problem? He can pinpoint that. How many doctors have missed the small dots that are seen in the scan report and the X-ray reports? So exposure and experience is very much important. So depth of exploration is one factor. And lateral extent also. Suppose this is the base of the footing, and lateral side also. I got a beautiful example for this, but we are running out of time. In the pillow scheme, we executed a tank. But at the end of it, I noticed there was a well nearby, close to that site. And the well was something like this. I asked them to close the well. Initially, they refused. When we calculated it, the well remains open. The moment water tank is loaded, it will collapse. But it was closed, then the water tank is in place. There is a master reservoir located along the Satiri. I can tell many, many examples where we have saved the buildings. Now, I talked about you should go for 10 meter, 15 meter. Now, borehole investigation is handy. Borehole investigation is one. The same SPT is conducted at every 1 meter or at every 1.5 meter. And we collect soil samples also. We take core samples also. So we are probably, these are the core samples that are obtained in our investigations. 1 meter core, only this much sample is, what does it indicate? Sometimes we get, recently, yesterday we got from a place, 1 full meter core, rock, intact. So it's quite interesting. Students, please see that. We cannot pre-conclude any formation of the soil. It is quite interesting. It differs from place to place. And these are some recovery. See, you need to have an idea about the geology also. What type of rock it is. You must be able to have some idea about it. And this is a bore log that we take. See here, just we have gone up to 10 feet for a particular project. And just, of course, this is probably, this is for our, in Valanglam pedestrian bridge. Now they are under smart city project. The projects are going on. There is a pedestrian bridge where we have designed that building also, designed that bridge, and we have done the soil investigation for that also. This is the profile you can see here. Water, it is being done underwater. Even students who are interested, you can go and see at least for 2-3 days. The investigation is offshore investigation to be done on a boat. You can see underwater we are doing the investigation in Valangulam. Just see here, water, muck, soft, it is a soft rock. So we can go up to 10 meters. I told you I have gone even up to 100 meters also in the Singapore sea. So just imagine, and how we classify the soil, how the penetration resistance. And before I close, I can tell you about the plate load test also. This is what I just told in all infrastructure projects for pile load test is being conducted. And there is a plate here, there is a jack, and this is the truss that is anchored to the ground. When you operate the jack, it will try to lift the truss. As a result, the reaction load will be transferred towards the plate. And probably you can just see here. I just projected, it's available in the book. I normally used to spend time in the examples, but so how we calculate? Again, here also the settlement is a factor. See here, this is the load settlement curve. Why settlement? Because the settlement has to be limited. This axis is load, ultimate load bearing capacity. How we take it? This is what the shear failure. This is what the shear failure. This is an indication for a general shear. This is an indication for a local shear failure. This is an indication for a punching shear failure. Just imagine. How we take that ultimate bearing capacity. How we take the safe bearing capacity from the ultimate bearing capacity. Ultimate bearing capacity divided by a factor of safety is the safe bearing capacity. So this is what probably analytical methods. Analytical methods, Tersaghi's theory is the main thing. The simple equation is Q ultimate is equal to CNC plus QNQ plus Q is nothing but gamma into DF plus 0.5 gamma B and gamma. This is of academic interest. Though I am basically an academician, I am a practicing engineer as well. These theoretical calculations doesn't hold good at all when you go for a field test. Always these theoretical projections will give only the conservative values, because we'll be collecting soil samples, conducting tests for C and phi, and those values will be inserted here. Collection of sample disturbance will be enormous. So I don't believe in this calculation unless we are not able to physically reach. See, sample from moon is collected and tested here for the shear strength. We cannot go to moon. We cannot conduct an SPT test. We cannot conduct a borehole test. So we collected the sample. We determined in the laboratory C and phi. We arrived at what is the shear strength. If you are really able to go to the place, you can go in for the field test, which is expensive and which is costly and which is reliable also. Don't be afraid of the cost. I can tell that every engineer or every student, that cost can be very much saved in the design. And this is what the latest IS formula, that is the Indian standard formula, that they have incorporated all constant. SC is a shape coefficient, Depth is a depth coefficient. IC is the inclination coefficient factor. See, just imagine. So only 3 components, CNC plus QNQ plus 0.5 B gamma N gamma. It is available in all soil mechanics book. But my only conclusion is this value obtained from here is very conservative. To the places where you cannot reach, you can still rely on this method. Otherwise, you can go to the field tests. But as an expert, or as an engineer, or as a consultant, as a practical person, you should consider all these factors into the mind before recommending your final factor of safety value. So probably I have just finished. I have taken Ilma. I have dragged almost up to 8 o'clock. I don't have time. I have got a lot of open. I have a lot of examples also. Quickly, I tell one example. Probably I can. Thank you. I just share one example. One of the leading personality in Coimbatore, who is residing in Ramanathapuram, is a film personality. He is having an existing building. It's a bungalow type building. All interiors finished. All interiors finished with wooden carvings and other things. And he was repairing his house almost every day. Almost every day he was every year he was repairing, because he will repair, there will be crack. Repair this year, there will be crack. After 5 to 6 years, he came to me. He asked me, it is cracking even after repairing the building every year. I asked him, provide 2 trial pits up to your foundation. One at the front, another one at the back, diagonally opposite to each other. After a lot of reluctance, he went. Then he said, I have made the pit. I went there to see, he had made only 1 pit. Then I told him, I inspected that pit. I could not find any reason for the cracking. I told him again, I rather requested him, sir, make 1 more pit. Let me complete, because I'm interested in giving solutions. Then he had made another pit. Then he called me, I went there. That pit also looked to be the same. But the funny thing is, you can see, the moment I got into the pit, moment I got inside, there was jet of water from one direction. I was surprised. Immediately I came out of the pit. I just tell you what has happened. There was a water supply line, disconnected water supply, but not plugged. So when the water supply was released in that area, that happened in Ramanathapuram. So this pipe full of water was jetting into his soil, foundation soil. So every day, whenever, once in a week, there was jet of water. It removes all the fines from the underlying soil. The foundation was settling down a bit. Then next week, same process continued. Next week, same process continued. You can see when the fines are removed, probably those people who are involved in the deep excavation combined with pumping, you will understand. When fines are removed, slowly the foundation will be settling. But there was a benefit on that investigation. He was able to rectify that, because I suggested grouting, it was grouter rectified. There was another benefit, that the engineer, I called him corporation engineer, only through him I confirmed that this is water supply. He said, sir, in this area there was complaint that the pressure is not sufficient. Now I have found a solution for this problem. When this is plugged, those people get plenty of water. So why I just told you this example, when an expert suggests, why don't you make 1 more pit, 1 more pit, please go ahead with that. Otherwise, we may not be able to come to a proper solution. So I have just completed it. I'll be happy if there are 1 or 2 queries, then that will give me the satisfaction also. Are there any queries from the student side?
Yes, sir. There are some questions posted by the students, sir.
Okay.
Let me read out the questions one by one, sir.
Please.
Sir, question number 1.
Okay.
How to evaluate the bearing capacity of existing buildings?
No, again, the same thing. Now this is a very...
You said this last answer, exact answer.
Or you read out all the questions?
Yes, sir.
Or one by... Okay.
Next. Is there any method to stabilize quicksand?
Okay.
How how to determine the PHA value, that is angle of internal friction of soil sample.
Okay.
What is the range for SBC in immediate settlement?
Okay.
Why clay has high limiting settlement than sand?
Okay.
So these are some questions.
These are the questions.
Yes, sir.
So the first one, in the case of the existing building, this we come across in many cases now. So you have to make or you have to conduct a test at the same level where the foundation is set. So we can only see the SBC of the soil. There is no SBC of the existing building. So for the soil at which the existing foundation is laid has to be tested. So once that bearing capacity is confirmed, now we can see additional floor can be constructed or not. If that SBC is not sufficient, you can go in for retrofitting. Micropiles can be inserted. The strength of the soil can also be improved upon. That is question number one. Another one is, can we stabilize quicksand? So it is actually a condition. Quicksand will occur in silt, and in dense soil it will never occur. So it is possible you can densify the soil. You can densify, suppose, I showed a sink hole also. How much quantity of sand can be pumped into that? Probably, I can tell you one example. In one grouting, in one block we grouted with cement, 5 bags are sufficient. In another block we grouted with cement, nearly 50 bags were involved in grouting that. So for densification, you can go in for grouting with the same sand, or you can adopt other grouting methods also. Quicksand is only a condition that is created because the water table will also be there. The loose silt will also be fine sand. Fine sand will also be there. So that can also be modified. And another thing, how to estimate the phi value, angle of internal friction. For angle of internal friction, we have to take undisturbed sample from the soil. Undisturbed sample from the soil. We can conduct the direct shear test in the soil. So using the direct shear test, we can determine C and phi value. Sandy soil, C will be almost minimum and phi value will be more. In the case of the clay soil, C will be maximum, phi value will be minimum. I don't remember the fourth question. What is
Why clay has high limiting settlement than the sand?
Pardon me, it's still not clear.
Why clay has high settlement than sand?
Okay. Why? No, that is because the permissible settlement of clay is given high because the settlement will not occur immediately. It will occur slowly. Even after a period of 2 years, 3 years, it will be slowly occurring. So the stability can be attained. So the compressibility is more and permissible settlement is also more for clay. Last one, sir.
One more, sir. When an underwater structure like pier are constructed, on what basis the strength of underlying soil bed is calculated?
No, that's what I told. This borehole method we have seen. I just showed you can the students, if they are interested, go tomorrow also to Arumairaj, where this borehole investigation on a floating boat is being conducted. So at every meter, we collect the soil, even underwater also, no problem. We collect the soil sample, we collect the rock cores also. So we can identify at what depth the foundation can be provided. So you can go up to 100-meter depth also. That's why I told you the seabed, very poor soil or soil with zero bearing capacity is available for 10 meter, 20 meter, 30 meter. Have I answered all the questions?
Sir, one more question, sir. Yes. How foundation for dam is constructed to prevent the seepage?
To prevent the
seepage in dams.
To prevent the
seepage, sir. To prevent
seepage.
The dam.
That is a good question, but it's a big area. Seepage is mainly due to, first we have to, geology comes into the role, and rock coring has to be done.
Sir, sorry to interrupt, sir. Can you please change over the admin, sir? Because there is a disturbance in the background which I want to correct. Can you just make me the host, sir? Now you are the host. Can you transfer the host to me?
How to do that?
சார் ஜஸ்ட் யூ கோ, there is 3 என்னோட படத்துக்கு வாங்க சார். மேல 3 டாட் இருக்கும் பாருங்க.
ஆமா ஆமா. ஓகே.
அந்த டாட்டை கிளிக் பண்ணுங்க சார்.
ஓகே.
அதுல கீழ பாருங்க எல்லாம் லிஸ்ட் ஆகும்.
மேக் ஹோஸ்ட் இருக்கு.
கரெக்ட் சார். ப்ளீஸ்.
அதுக்கு okay, I
sir,
think
thank you. Sorry for bothering. Please continue, sir. Please continue.
Because you have to take control of the participants, you know.
Yes, sir.
I am
please proceed.
To just deliver what is available.
Please proceed, sir.
Dam seepage, actually, basic thing is we do extensive coring in the rock. And rock, if you look at based on the RQD, இப்போ நான் உங்களுக்கு சொன்னேன் 1 மீட்டர் கோர் பண்றோம்னா அதுல வந்து பீஸா வரும். அந்த படத்துல கூட நீங்க பார்த்திருப்பீங்க. That means it is highly weathered. The rockல fresh அப்படின்னு ஒரு கேட்டகரி கொண்டு வருவோம். அந்த fresh அப்படின்னா 90% மேல கோர் ரெக்கவரி இருக்கும். இப்போ even in one particular place yesterday we got 1 full meter core as it is. ஸோ அப்படின்னா என்ன இண்டிகேஷனா, இப்படி நிறைய கோர் போட்டுட்டு அந்த கிராக்ஸோட பிக்சர் அந்த அலைன்மெண்ட்டை மேட்ச் பண்ணுவோம். எப்படி இந்த ஃபிஷஸ் வந்திருக்கு, எப்படி கிராக்ஸ் வந்திருக்கு. Then that will be grouted. So that is first thing that we do. So all tunneling எப்படி பண்றோமோ அப்படி ரிவர்ஸ்ல இமேஜின் பண்ணுங்க. So all rock will be grouted with cement or if you necessary with some other chemicals also. That is one thing. Then in the concrete. So concrete wall, if it is a concrete wall, then probably the concrete you have to take care of the impermeability. Main thing is the sealing of the cracks in the rock. Extensive coring, identifying the cracks and fissures, doing the grouting. But that's why I just mentioned, we do not know how much cement bags need to be pumped into. That is one fact. Is it okay?
Okay, sir. Okay, sir.
சார் ஒரு கொஸ்டின்ங்க.
சொல்லுங்க சார்.
நம்ம அந்த ஜீரோ பேரிங் கெப்பாசிட்டி சொன்னோம்ல சர்டன் ஏரியாவில் சார்.
ஆமா சார்.
அந்த கண்டிஷன்ல நம்ம என்ன ஃபவுண்டேஷன் என்னதான் பண்ண முடியும் நம்ம?
So two things. ஜீரோன்னு நான் ஒரு 10 மீட்டர் 20 மீட்டர் சொன்னது எல்லாமே வந்து ஆஃப்ஷோர் ஸ்ட்ரக்சர்ஸ்.
Okay.
Needed to be rested on bedrock only.
Okay.
So in such cases we go for pile foundation or a pier foundation.
Okay.
உங்களுக்கு ஒரு சின்ன எக்ஸாம்பிள் சொன்னா, நீங்க இப்ப சூலூர்ல ஒரு பஸ் ஸ்டாண்ட் கட்டியிருக்காங்க. That was investigated, designed and even I did as a third party inspection also. குவாரியில இருந்து அப்படியே ஒரே பியரா போட்டு அதை காலம் போடுறதுக்கு பதிலா சர்க்குலர் பில்லரா போட்டு அப்படியே இப்ப இன்னைக்கு அது தெரியாது. அந்த குவாரி வந்து about 30 feet or 40 feet டெப்த்ல தான் இருந்தது. ஸோ சிமிலர்லி ஒரு பியர் லைக் ஃபவுண்டேஷன் இஸ் ப்ரொவைடட் கேசிங் வச்சு, then on that you support all these structures. அது வந்து மேஜர் ஸ்ட்ரக்சர்ஸ் ஆஃப்ஷோர் ஸ்ட்ரக்சர்ஸ் தான். இந்த ஜீரோ பேரிங் கெப்பாசிட்டி நம்ம ஹில்லி ரீஜன்ஸ்ல பார்க்குறோம் சார். அதுல என்னன்னா பிகாஸ் ஆஃப் திஸ் பிடி சாயில், தட் இஸ் ஆர்கானிக் சாயில் பார்க்குறோம். இதுல 2 ஆஸ்பெக்ட் இருக்கு. நமக்கு 10 டன் கூட கிடைக்காது, இல்லை 5 டன் per ஸ்கொயர் மீட்டர் கூட கிடைக்காது. ஒன்று அந்த சாயிலை ஸ்டெபிலைஸ் பண்ணலாம். ஸ்டெபிலைஸில் வந்து சம்டைம்ஸ் யூ மே ஹேவ் டு ரீப்ளேஸ் இட் ஆல்சோ. இஃப் ரீப்ளேஸ்மெண்ட் இஸ் ஓகே சீப்பர் யூ கேன் டூ தட். Otherwise, now this geotextile have come in handy. So you can do that geotextiles. You can lay it layer by layer. And in hilly regions, now you know the construction of buildings restricted to only G+1 floor. So the loading will also be limited. So there we have to go, we can think of even floating foundation also. So floating foundation is a critical design. So what is the amount of soil we excavate from the base can be replaced by a building. So definitely the soil will have some unit weight. So if you provide a depth at 3 meter, at 3 meter weight of soil is active. Soil is stable. So now this 3 meter weight can be replaced with a building structure that you plan. So floating foundation can also be part of it.
Okay. Okay. Yes. Thank you, sir. கார்த்தி, வேற ஏதாவது கொஸ்டின் இருக்குங்களா?
இல்லைங்க சார், அவ்வளவுதான் சார். கொஸ்டின்ஸ் முடிஞ்சது.
கன்க்ளூட் பண்ணிக்கலாமா?
கன்க்ளூட் பண்ணிக்கலாம் சார்.
சார் ரொம்ப என்ன சொல்றது, யூஸ்ஃபுல்லான ஒரு செமினாருங்க. அதுவும் எங்களை எல்லாம் சைட்டு கூட்டிட்டு போனீங்க, கிளாஸ் ரூம் கூட்டிட்டு போனீங்க, காலேஜ் கூட்டிட்டு போனீங்க, லெபார்டரி கூட்டிட்டு போனீங்க. எஸ்பெஷலி ஸ்டூடெண்ட்ஸுக்கு மட்டும் இல்ல, எங்க சைட் இன்ஜினியர்ஸ் மற்ற எங்களை மாதிரி ப்ராஜெக்ட் இன்ஜினியர்ஸ், பில்டர்ஸ் எல்லாத்துக்குமே ரொம்ப யூஸ்ஃபுல் இன்ஃபர்மேஷன் சார். கண்டிப்பாக இதை வந்து நாங்கள் நம்ம ரெக்கார்டிங் வந்து ஸ்டூடெண்ட்ஸ்க்கு ரொம்ப யூஸ்ஃபுல்லாக இருக்குன்னு நினைக்கிறேன். ரொம்ப நன்றிங்க சார். தேங்க்யூ ஸோ மச். கண்டிப்பாக அது மாணவர்களுக்கு பிரயோஜனமாக இருக்கும். மேலும் இந்த நிகழ்ச்சியை ஒருங்கிணைத்த டாக்டர் கார்த்தி அவர்களுக்கும் எங்களது மையத்தின் திரு பிரகாஷ் சங்கப்பன் அவர்களுக்கும் கவின் டாக்டர் முத்துப்பிரியா அவர்களுக்கும் நன்றியை கூறிக்கொள்கிறோம். விடைபெறுகின்றேன் சார். நன்றி சார். மீண்டும் சந்திப்போம் சார்.
Nano, I just want to thank all of you. Again, once again, I take this opportunity to thank every one of you. But I know you are the real people in the field. So probably we'll continue to have interaction at the one time for the members also.
Yeah, please.
All the modern developments in the geotechnical engineering, because infrastructure is everywhere now. Project. So you are the people who are actually in the field. We can design, we can suggest, but you are the person to decide whether to implement it or not. So probably we can continue to meet again. I thank every one of you. Of course, I know the president very well. I have got the familiar faces also. Dr. Muthupriya, I know her very well. And Dr. Prakash, and some faces are familiar, but I could not thank every one of you. I take this opportunity to thank every one of you. Thank you.
Thank you, sir. Thank you so much. Thank you.
Chairman, thank you, Chairman.
Thank you.
Thank you.